Okay, welcome everybody. Okay, so we're kind of getting to the point where we're largely wrapping things up. um, First of all, let me just start off. I apologize. I'll be chewing gum today, which is when you're giving a presentation, especially if it's sort of visual and audio and stuff. Chewing gum is generally not a great idea. It's unprofessional, but it seems to be one of the few things that's just keeping me from coughing uncontrollably at the moment, which makes it very hard to give a lecture if I can't stop coughing. Um, so that's why. It's not that I'm unconcerned or anything. It's that I just don't want to be coughing for the next hour. Um, so I'll try to not make it obtrusive or anything like that. But I'm chewing gum because then I can stop coughing and talk for a few minutes. So please, you'll have to excuse me today for doing that. We're wrapping up. I think we should be able to wrap up chapter 7 today. We may not completely wrap it up, in which case it will carry over into Tuesday. But otherwise, Tuesday will be kind of review for the final. Your practice test will be out early next week. You can work on that. And then you will have your final exam, which will be then, closer to finals will be up for you, and then you can take that. Okay, and we can talk about specific dates a little bit more next week. I probably will. My plan, at least, is to put the practice test up Monday. So some of you could even work on the practice test before Tuesday, and then if you have questions, you could bring those questions to class. Because if we have a review, it will be student driven. It will be question based, because it took us weeks to cover this material. I'm not sure what you need to see, what you don't need to see. Everyone's a little different. So you need to come with questions, and you can say, well, this one topic in the homework I'm still having trouble with, and then I'll pull up the homework and we'll look at it. But otherwise, if I'm just randomly picking topics to cover, that's usually not very effective. So that would be one way of doing things. If you have other questions you want to ask on Tuesday that aren't based on the practice test, go ahead and ask those. Right? Bring questions, whatever you think you need in order to finish this class successfully. Bring those questions, and we will go over that stuff. Okay. Right. So with that said, we have class today. Our last class will be Tuesday, and then you will have to complete the exam by the time of the final. That has to be completed by that time. I cannot take any scores that are done after that time. So make sure you complete it by then, and then we'll talk more about Tuesday, about kind of wrapping up the course. Okay, so a couple things we need to look at here at the end. So there's this topic of complex fractions, which I think we should go over. Oops, let me get this window right. It's kind of weird how it's over like that. This window is sizing weird. It is not giving me a scroll or horizontal scroll, which is odd. Anyways, here we have an example of a complex fraction, and we want to fully simplify it. That's generally what you want to do with a complex fraction, is simplify it. So what is a complex fraction? A complex fraction means you have a fraction inside of your fraction, right? So you have one fraction. We can see there's a big fraction here with this numerator on top, 1 minus 1 over x squared, and the denominator 1 over x plus 1 over x squared. That's the denominator. So there is a big fraction, and then embedded inside of our big fraction, we have 3 smaller fractions. So that makes it a complex fraction because there's fractions within our fractions. Now, I think this is one case where it's pretty easy to see why simplification is important. Most people already get a little bit nervous when they have to deal with fractions, right? When we tell them something like, 3/5 of the student population support the vaccine mandate. I'm just making up this example, but if you tell people 3/5 of the population support the vaccine mandate, many people will just look at you and go, what is 3/5? What are you talking about? What does that mean? 3/5 means 3 out of every 5, which would be 60%. So that's 60%. So hopefully what I just said is comfortable for most of you, and you're like, no, I understand what that means. That's great. Some people still get confused by that. Then start talking about have fractions inside of your fractions. Now people are really going to get confused, right? Even if you're comfortable with fractions, it starts getting confusing when I tell you a fraction that has fractions in it. And you got to go, wait a minute, I got to see how to simplify this. So this is one case where I think it's pretty obvious why we simplify problems like this, because no one understands what these things are when we have fractions inside of fractions. It's just ridiculous. So we want to know how to simplify a fraction that has fractions inside of it. And the good news is it's not too bad. Basically what we're going to do is similar to a technique we're going to use that we've used before and that we're about to use again in our not rational. Why am I searching for the wrong word here? Oh, yeah, it is the right word. That's why I kept thinking of it. Because when we look at our rational equations that we go to solve, it was the right word. Which is we're going to get rid of the fractions that we don't want. Okay, that's our tool here. So what we want to do is look at this fraction, and we first look at all the small fractions. So, we have the one big fraction, which is kind of the whole thing. And then embedded inside of that, we have three smaller fractions. So when I talk about the big fraction and the little fractions, you know which one I'm talking about. This whole thing here is the big fraction. The little fractions are the ones occurring in the numerator and the denominator of the big fraction. So what we want to do is look at the denominators of the little fractions and ask ourselves, can I get rid of those? Can I come up with something to cancel those denominators out? And the answer is yes. And then we want to multiply the top and bottom of that fraction by the thing that is going to make those denominators cancel. So I look here, I have three denominators in the little fractions. I have an x squared, and an x. Well, if I multiply all of those fractions by x squared, the x will cancel out, this x squared will cancel out, and this x squared will cancel out. You're just back to looking for your least common multiple, right? What's the smallest thing that x and x squared both divide into evenly? That's what we're going to multiply by. So you can see we've got our problem written here. Oops, I should scroll up a little bit. We've got this. So what I'm going to do is I'm going to multiply the top and bottom. Notice we don't have an equation, we have an expression. I'm going to multiply the top and bottom by the value that's going to make all those little denominators go away, which in this case will be, oops, we want to go that, and then the fraction x squared over x squared. Okay, so I'm just taking the fraction x squared over x squared and I'm multiplying it by this big fraction. Now, here's a mistake I see people do, is they know the reason we're multiplying this in is to get these little fractions to go away. So they don't multiply by this 1 over here. But we can't pick and choose what gets multiplied by x squared. We have to follow the rules of the multiplication. So when I, let's see. When I distribute across the top, 1 times x squared is x squared. Okay, so I get an x squared. When I multiply 1 over x squared times x squared, what do I get? In that case, I get a 1 because x squared over x squared is 1. Think of, if you're having trouble seeing those multiplications, think of this x squared as being x squared over 1. X squared over 1 times x squared over 1. Right? You could think of it as that way. There's numerous ways to write this up which are valid. So that would be x squared minus 1. And then on the bottom, when I multiply x squared times 1 over x, well, x squared over x would give me an x. So on the bottom we have x plus, and then x squared over x squared is 1. Does everyone see how that's what we get? If there's any questions, feel free to ask. But that's what this becomes. Now, we can do some simplifying, but we don't want to do it in a sloppy or incorrect way. what I see people do sometimes, they go, oh, here's two ones. I'm going to draw a line through those ones. And here's an x squared and x. I'm going to draw a line through those x's, and that leaves me an x on top. Nope. Can't do that. Remember, canceling is a division property, so we have to divide the top and bottom by the same thing. So we're not quite ready to do that, but let's jump to this next step. So remember, what we're going to do if we want to simplify, we have to factor the top and bottom. So that's going to be x plus 1, x minus 1. That's a difference of squares on top. Okay. Now we can cancel the x plus 1, and we're left with x minus 1. Okay, so when we go to our answer here, this should all become x minus 1. And there we go, we got it. So you can see they did the same thing. They wrote it up slightly differently than me, but they multiplied by x squared over x squared. Actually, the way they wrote this up, I think, is actually not the cleanest way of doing it, but if you do it this way, that's fine. I just find students find this way a little bit more confusing. So you can do it the way I showed you. You can do it the way that they're showing you in the video and the answer here. That's fine. Yeah, I feel like the way they write this up is way more confusing than it needs to be, but whatever works for you. Okay, so that's the complex fractions stuff. Feel free to ask questions if you have any. All right, so let's get into rational equations. So this is where we have equations that have rational expressions in them. So it's really important that you distinguish between equations and expressions. We make a big deal out of this numerous times throughout algebra, and many students continue to struggle with it. And I think sometimes there's this tendency of like, who cares? Who cares what's an equation and what's an expression? And then those students get those problems wrong because they're failing to see why it's important, right? So then they struggle on a problem like what we're looking at now. The reason it's important, whether you're dealing with an equation or an expression, is because we have different tools that we can use for equations and expressions. So we have one way that we've been doing things for most of this chapter, and it's a little bit what I would call the harder way to do things because we excuse me. We kind of were limited because we didn't have an equation. We only had an expression. And so one of the tools that we're going to be using a lot today is one of the things you've been using throughout much of algebra, which is to multiply both sides of the equation by the same thing. Well, that only makes sense if you have an equation. How could you multiply both sides of the equation by the same thing if you don't have an equation? And that might sound silly, but I see students do it all the time. They take an expression and they try to cram it into being an equation because they're like, oh, if this was an equation, I think I know what to do here. And they try to force it to be an equation. Or they take an equation and they treat it like it's an expression, and they end up doing it a much, much harder way, and then they don't end up finishing the problem. So it's really important to identify the things we've done up to this point in this chapter were all expressions. Okay, the way that we are going to finish the equations is by treating them as equations, right? Which again, sounds obvious, like, oh yeah, you're going to treat equations like equations, but it's important because I see students try to solve these like they're expressions, and then they just get kind of confused and lost, And I see what the other thing I see students do is force expressions to be equations. They say, I'm just going to pretend it's an equation and go from here, because then I can multiply both sides by something. But once you just start making up your own rules, then you've sort of deviated from reality, right? Obviously, it's not going to go well. So always recognize, am I dealing with an equation or an expression? And then, of course, always read the directions, because those have some helpful hints in them as well, being as they are literally the directions. Okay. So what would I try to do here? First, I want us to walk through a solution, and then I'll work one out. So actually, is this the one I want to walk through? Let's do... do this one. This one might look scary, but it pretty much takes care of all the steps that we need to discuss. Okay, so the first thing we're going to do is find the least common multiple of our denominator. So the goal, like here's how we're going to do things. The goal of solving a rational equation is to get rid of the rational part. That is to get rid of the fractions, which probably is good news for most people listening. They're like, oh, great. We're going to take an equation with fractions and we're going to turn it into an equation without fractions. Awesome. I'm on board. Good. Because that's how we're going to do it. You should be aware, though, there's a small price we have to pay for getting rid of the fractions. And that small price to pay is that you have to check your work at the end of the problem. And sometimes these rational equations can be kind of a pain to go back and check your work. But the thing that we do to get rid of the fractions can also introduce extraneous solutions into your problem, which means you can do all your work correctly and get down to the bottom and it says x equals 2. And you're like, great, I solved it, x equals 2. But when you substitute x equals 2 back into the problem, it doesn't work. And you're like, wait a minute, what's going on here? It's because that x equals 2 is an extraneous solution, therefore not actually a solution. So this is one of those scenarios, again, where when we tell you to check your work on solving rational equations, it's not just because it's a good idea to see if you can catch any of your mistakes. It's because literally you have to. It's part of the process. If you don't check these, there will be times where you find solutions. Even though you didn't make any mistakes, you'll get an answer to a solution that is, in fact, not a solution. Okay? So keep that in mind. So what we do is we look at the denominators and I go, well, if I'm going to get these, like we did a minute ago in that previous problem of the, whoops, Zoom just did something weird. Let me fix this. The previous problem we were just looking at of the complex fractions, what did we do? We looked at how to get all of those little fraction denominators to cancel out, because once those denominators are gone, they're not fractions anymore, and you're just left with the one big fraction, which in the problem we did happened to simplify to something that wasn't a fraction anymore. But our goal was to get the little fractions out of the big fraction. We did that by canceling out the denominators. That's what we're going to do here. We're going to figure out how to get this x plus 3, this x minus 3, and this x minus 3 to cancel out. Well, the way we're going to do that is by multiplying by the least common multiple of the denominators. Well, we know we need a factor of x plus 3 in there, and we know we need a factor of x minus 3 in there. So, okay, great. X plus 3, x minus 3. We're going to multiply the entire equation by x plus 3, x minus 3. And you can see that's what they did here, right? You can see them. They're multiplying by x plus 3, x minus 3 there, here, here. Every single term in the equation gets multiplied by x plus 3 times x minus 3. Now, it's kind of like what I mentioned in that last problem that we did a minute ago, where sometimes people will pick and choose what they're multiplying by. Remember the rule that we're using. It doesn't say multiply the terms that you feel like multiplying by the same thing, right? We've never stated the rule that way. It says multiply everything on one side of the equation by the same thing that you multiply everything on the other side by. Everything has to get multiplied by, right? This goes back to the whole when we're first learning this and you have like the scales, if you have weights on like a balance and it's balanced out and you double the weights, they're still going to balance, right? But if you double the weights on one side and then you only double some of the weights on the other side, they're not going to balance anymore, right? So you have to multiply everything. Everything gets multiplied by that LCM, okay? A lot of times what I see is people only multiply the terms where they want the denominators to cancel, but you got to multiply everything. Okay, so they did that. So look what happens here in this case. This x plus 3 is going to cancel with this, this x plus 3 in the denominator. It's not letting me highlight it. But this x plus 3 down here cancels with this x plus 3. This x minus 3 cancels with this x minus 3. And both of these cancel over here. So in other words, what we end up with is over here we have the 2 that remains in the numerator. The x plus 3 cancels, so we have 2 times this x minus 3, right, becomes here. Here the x minus 3's cancel, so we have this x plus 3 left and this 3 left, so it becomes 3 times x plus 3. And then here on the back end, well, they did this in kind of a weird way, actually. Hold on. I think they have a typo in here. This doesn't seem right. Hold on one second. Sorry, but if there's a mistake, I want to make sure I can tell you so you don't make, so you know what's going on when you try to do the same thing. So let me figure out what exactly they're doing here. 2 x plus 3, 3 x minus 3, x minus 3. All right, so their final answer is correct, but this line is weird. It should just be x on this side. They're doing something weird here. 2x minus 6 through x plus 9 equals x squared plus 6. They have this line is not clear what they're doing here, because it should not, from the right we should not get x times x plus 3, we should just get x. So they're doing, oh, I know what's going on. Here's where the typo is, right here. Okay, this makes more sense. This part is correct. This line above it is incorrect. Look how they changed this denominator right here to be both factors when they rewrote it. So it looks like they should both cancel, but they shouldn't, because this down here should only say x minus 3, not the x plus 3 part. So they do have a typo in here, but then they fix it. I mean, they recover afterwards, but this part of their code, when they generate this page, this part of the code has a typo in it. Okay, sorry to take up a few minutes for that, but I couldn't figure out where they were doing it wrong. It's right here. So you end up with this, which is nice, right? You end up with this, which doesn't have fractions anymore. And we're so excited because we're glad that the fractions don't exist in the problem. But again, we have to pay the price for it. So you just solve this like we did in, was it one chapter back where we, yeah, I think so. Using the chapter 6, solving quadratic equations, stuff like that, we can solve those. So you basically go through and do that. So see how they get 0 on one side of the equation, they factor the one side, and then they solve for their answers. Now, we got two answers to this equation, or they did, the way they do it right here. But notice how one of them's not right, because let's take this 3. What happens when I go back and I plug 3 into this original equation right here? Well, look at our second denominator. It's x minus 3. So when I plug in 3 minus 3, I get 0 in the denominator of a fraction. We're not supposed to get 0 in the denominator of a fraction. That doesn't make any sense mathematically. So we'll get rid of that. And so we get rid of that answer. 3, like we didn't make a mistake when we got, let's see, where is it? When we got -1 and 3 as solutions to this equation, that's correct. But notice when we go back and plug it into the original equation, it doesn't work. That's the price we have to pay for getting rid of those fractions, is that we introduced the 3 as an extraneous solution. So we have to get rid of it. Okay? So that's what they do here. They check them both to see if it gives us any problems in those denominators. And sure enough, one of them does. We get 3 over 0 in that second denominator. So we have to reject the 3 as a solution. So we had 2 solutions. We rejected the second one. That means the solution is the first one. And you're going to get all sorts of combinations. It's possible to get 2 solutions and you reject both of them. It's possible to get 2 solutions and you reject one of them. It's possible to get 2 solutions and you reject none of them. So you never really know what's going to happen until you check them. So you have to go through and check the values in order for them to make any kind of sense, unfortunately, right? Okay, so that's how those problems go. And it's basically the same thing every time. Whoops, let's go back here. Let me just remind myself what this one looks like. Here, if you've got a denominator like these two, what are you going to do? You're going to factor the second one, right? That one's not too bad. Yeah. Okay. Let's go back and do this one. Okay. So here's the problem that I want to do. So let's look at that. So I've got, what, 1 minus 1 over x plus 2. And then 2x so x squared plus 8x plus 12. Okay, so is that right? 1 minus x plus 2 equals 2x. Okay, so we want to solve this thing. I don't know what I'm going to multiply by until I know what the factors of this polynomial are. So guess what I'm going to do? I'm going to factor the polynomial. So we're going to have basically the same thing except in the factored form. In fact, let me just copy paste this. And then we will change this part to, let's see, what's it going to be? X plus 6x plus 2. Okay, so now I know what the factors I need are. So my list of factors I've got what? We need an x plus 2. We have two denominators that need an x plus 2 and one denominator that needs an x plus 6. So this is our least common multiple. Everything's going to get multiplied by that. Remember that long line they had in the last solution, which actually had the typo in it? But you could see everything getting multiplied by x plus 2, x plus 6. That's where we're going. That's what we're doing. Okay, so now it's going to get kind of long. I got to write this out well. So let's see. If we multiply 1 times x plus 2, x plus 6, we just get x plus 2, x plus 6, right? So x plus 2, x plus 6 minus the fraction x plus 2, x plus 6 over x plus 2 equals, now we get a new fraction. It's going to be 2x times x plus 2, x plus 6 over x plus 2 x plus 2, x plus 6. Okay, so what just happened? What did I do? I took this entire equation here and I multiplied everything by x plus 2, x plus 6. So the 1 just became x plus 2, x plus 6. Oops, that should not be that should be a subtraction, not an equal sign. Let's let that update. Okay, then minus this term. So remember, like, we can really think of this x plus 2 over x plus 6 as being the fraction x plus 2, x plus 6 over 1. Sometimes that's helpful to students. It doesn't really matter to me if you write it that way, but let me give it a little space so we can see it better. Do you see how x plus 2 over x plus x times 2 times x plus 2 times x plus 6 is the same as x plus 2 times x plus 6 over 1. But I see students get really confused when they're multiplying some things that are fractions by some things that are non-fractions. So if it helps you, write it this way. If it helps you to take this and multiply it into each term right up there, do it that way and then simplify. Or some students are just comfortable multiplying it this way. Whatever works for you. They're both mathematically legitimate, but you have to understand what you're doing. Okay. So then we've got this here. And this looks like it's getting out of control, except the good news is now a bunch of stuff is going to cancel. So what will happen is we'll take this same form, except now here the x plus 2's are going to cancel each other out, right? So this x plus 2 is gone. Becomes a 1. And then over here the x plus 2's and x plus 6's cancel on the bottom and the top. So we're left with like this, okay? Because these x plus 2's canceled. So we're just left with this x plus 6. In fact, we don't even really need the parentheses anymore. And then over here, the x plus 2 is canceled and the x plus 6 is canceled, leaving us with a 2x over 1. In other words, we now have an equation with no fractions in it because this whole thing becomes, let's multiply out. What is x plus 2, x plus 6? Let's FOIL that. It's going to be x squared plus 8x plus 12. In fact, we already knew that because it was our original denominator at the top of the problem, right? But anyways, it's going to multiply out to that. And then we get minus Now, here's where we have to be careful, because watch how I'm going to write this. Because we're subtracting x plus 6, but watch if I just write it as minus and then x plus 6. So this is wrong. Why is this wrong? But I see a lot of students do this. Why was it wrong if x plus 6 is really a 1? Well, this negative is applying to the entire numerator. But the way I wrote it, the negative is only applying to the x. So what you should do is make sure you recognize that you have to distribute that negative into the entire factor. So in that case, leaving the parentheses can be helpful if you're a person who makes that distributive mistake and doesn't distribute the negative. It can be a bit of an issue. Okay, so see how I left it like that? And then equals 2x. Okay. All right, now what do we do from here? Well, now we just solve this equation like you did in previous chapters. So let's see. We're going to get what? X squared plus 8x plus 12 minus x minus 6 equals 2x. So all I did here was distribute the negative into the x plus 6. So simplifying that, we're going to get x squared plus 7x plus 6 equals 2x. All right, I'm just combining like terms on the left there. Now let's subtract 2x from both sides. So if I subtract 2x from both sides, I'm going to get plus 5x. And then plus 6 equals 0. Okay. So now we have to factor the left side. Equals 0. So that means we're going to have what? X plus 5, x plus 1. And then when I go through and solve that, I'm going to get x equals negative 5 or x equals negative 1. So 5 and negative 1. So now let's go back and see if any of those are going to give us issues in the original problem. Basically what you're looking for, do any of the answers we just got, which are negative 5 and negative 1, do they give us a problem when I plug them into the denominator? Are we getting 0 in any of these denominators? If not, then we should be okay. But remember in the last problem where we plugged the 3 in to x minus 3 and we got 0 in the denominator? That's when the problem occurs. So if I didn't mess up a sign somewhere, the answer should be negative 5, negative 1. Let's see. So see how that time we got two solutions and they both worked, or I think they both work. Let's see. Uh-oh. Okay, what did I do? I did something wrong here. Let's see what I did wrong. Let me go back and look. If you see what I did, feel free to point it out. I probably messed up a sign somewhere. I'm not seeing the mistake. Let's see. I factored it wrong. Okay. Bad factoring on my part. Let's see, plus 2 plus 3, 5, and... Oh. Yeah, bad factoring. Trying to factor in my head. That's not the right factoring, because if you do 5 times 1 is not 6, right? So it's bad factoring. I was focusing on the other part, and I messed up the factoring. So same idea, except my factoring was bad. It should have been -2, -3 as our solutions, because the factoring should have been x plus 2, x plus 3. But the process we just went through was the same. You can see they even get to this part the same as we did, except I just messed up the factoring because I was focusing on not messing up the other parts, and then I messed up the easy part, right? But then notice what happens. They get 2 answers, and one of them gets rejected because it's an x minus 2. And if you plug in -2 to this original one, you get 0 in the second denominator. So if you get 0 in one of those denominators, it's not going to come out right. Okay? So that's basically how you do those problems. We don't have time. Whoops, we don't have time to do another one. Can't do another one in like 4 or 5 minutes. So that's where we're at. So make sure you're moving ahead in the homework. Make sure you ask me questions. The best time to ask me questions is Tuesday. Bring questions on Tuesday. Questions from the homework, questions for the test, questions from the practice test, which I think will be up Monday. Any of that kind of stuff, ask me about it. That's basically what we're doing on Tuesday. And the meeting probably will just take place in Zoom. I'll probably start off with it being on YouTube as well, but then I'll probably close down the YouTube stream. So that unless we have a lot of questions coming in, we might just move it over to the Zoom meeting. So we'll have to see how that goes. So why don't we sort of wrap it up there? I'll close down the YouTube stream. If you have questions for me now, hop into Zoom right now. I'll leave it open for a few minutes. Hop in there, ask me questions. I'll help you out. You can work on stuff over the homework and be kind of ready to start off strong at the beginning of the of next week. Okay, thanks everybody. We'll see you in a few days.